In order to prevent its misuse, we at IIT Bombay have Trust Lab, dedicated to answer all the questions that an enterprise has regarding its data security. In the next hour, the experts and researchers in this field would enrich us with their talks.
The moderator for this session is Professor Manjesh Hanawal. Professor Manjesh is an associate professor at IIT Bombay with the IEOR department. He is also presently serving as the professor in charge of Technocraft Center for Applied AI. Professor Manjesh has a PhD from the University of Avignon, France, and an MSc from IIT Bangalore. His research spans machine learning, communication networks, and cybersecurity, focusing on online learning algorithms, resource allocation in networks, and threat detection in cybersecurity. He's previously worked as a scientist B at Center for Artificial Intelligence and Robotics in Bangalore.
Our first speaker for this session, Professor Manoj Prabhakaran, is the Vijay and Sita Vashi Chair Professor in the Department of Computer Science and Engineering at IIT Bombay. His research interests span theoretical cryptography, information security, and various topics in the theoretical computer science and information theory. He has received an IBM PhD Fellowship, an NSF Career Award, a Beckman Faculty Fellowship, and a Ramanujan Fellowship. He is presently the professor in charge for Trust Lab.
Our next speaker, Professor Mondal, is an assistant professor of computer science at IIT Kharagpur. He completed his PhD from the Max Planck Institute for Software Systems, Germany in 2017. Professor Mondal is broadly interested in incorporating human factors into secure and private systems and consequently designing usable online services. His work also received Distinguished Paper Award in Usenix SOUPS, Google India Faculty Research Award in 2022 and IITB Trust Lab Early Career Award in 2023.
The next panelist is Dr. Faruk Kazi, who is a distinguished alumnus of IIT Bombay, where he received his PhD in 2009. He is currently working as a professor and dean of research and development at VJTI. He is a senior member of IEEE and is a recipient of AICTE Visvesvaraya Best Teacher National Award in 2020.
Our esteemed panelist, Mr. Prashant Deo, who also happens to be the session speaker for this session, is the CTO of Cybersecurity Business Practice at TCS, where he also heads the research and innovation within the practice. He has more than 25 years of experience in cybersecurity, consulting and operations. Mr. Deo specializes in devising security strategies and cyber resilience assessments for leading companies across industries. We are delighted that Mr. Deo could join us today to give the industrial perspective to this session. We welcome you all to the session on data security. So I'll call on stage Mr. Prashant Deo to give his session address.
Hi, good afternoon, everybody. I think the session post lunch, so I'll try to keep it little light. I think in morning session we heard about leverage of AI into healthcare industry, into military services, and there are so many applications which we heard about. And I think speakers also spoken about cyber security, how important it is to make sure AI becomes successful. Right, and how data is critical for it. So I come from a practice. Part of our business, we go to enterprise customers and even defense services to sort of consult, advise, and make sure whatever models been created, how those can be safely adopted. So I'll be happy to share our experience and what we see actually in practicality and where the things needs to be improved and all that. So I think we all know this post adoption of ChatGPT, the things have really started getting democratized, right? Prior to that, predictive generative AI was anyway there, right? But then I think since this last year and a half, post open AI and ChatGPT has started, everybody started leveraging this, right? And I think theme of moving from idea from lab to practice, I think it is really moved away now from idea to lab to, and we do see a lot of operationalization of AI as well as the Gen AI. I'll talk about it. But when we talk about it, obviously the downside of it is that there are risks, and these are some of the incidents which I think most of you would be aware, where because of poor design or poor configuration of these systems, it led to a data exposure, right? It led to a reputation loss, data exposure, right? And I think the training plays a very important role. We recently seen this, right? The multimodal Google released Gemini, right? There was because of the data and then because of lack of training, we do see the outcome, right? So there are large repercussions if it is not been clearly built, and if it is not been trained, if it is not been tested, right? So it has got a lot of application we've spoken, but I think in principle, if the data discipline and cybersecurity discipline is not been taken care, it has really a challenge for acceptance, right? Now, from a practice perspective, what we hear from customers when we go and sell, right? As a TCS, we sell the services around AI, secure AI. Two things what comes out, right? Two dimensions of AI. The first one is how do you de-risk an AI adoption, right? Very critical. I mean, when we speak to CIOs, your CISOs, or for that matter, business stakeholders, the first question comes is, while AI is doing good, but how do we make sure we do a de-risking of AI? In terms of identifying specific threats, specific vulnerabilities, making sure the regulation has been understood and making sure it has been adopted, right? So de-risking AI becomes very critical from an adoption perspective, and I think as part of your innovation, as part of your application in various sectors, I'm sure you would be really taking care of this part, but most of the time, I think security and privacy is always overseen, right? So in AI world also, we see that. Second thing, what we see is how AI can be leveraged for cybersecurity, because I think the power of AI, which can be used to do a lot of offensive techniques and defensive techniques, and I think my services colleague will appreciate that. But on cyber side, right, where there are so many state-sponsored attacks, nation-state actors, there are so many various actors. How can you leverage the power of AI to improve your offense capability and defense capability? And that is where we seeing good amount of traction also happening beyond the de-risking of AI. The way we look at de-risking of AI, right? These are some of the dimensions. When we go and basically promote an AI, these are a couple of things what we basically promote. It starts from basically making sure there is a basic discipline of AI security, right? We call it as the AI security assurance, enterprise AI security assurance, which runs around the various enterprise discipline. I'll talk about it, but it becomes so critical. But the way AI adoption is happening so fast, most of the time it has been overlooked, right? So very critical to have this discipline in place. And I was glad to hear, I think on the services side, you are starting AI council, and it's a cross-functional where the security policies and then those fundamental practices been also factored in before you are starting those initiatives, right? So on commercial enterprise side also it becomes so critical. Second thing, and I think that was the theme for today, how do you protect the live bird of AI, right, which is the data, right? Because if there is no data, I don't think so AI will be successful. So there is always a debate whether data is for AI or AI for data, right? The answer is I think data, without data there is no AI, right? You need a data. And what kind of data is required, I think we almost aware about it, right? But protecting that data becomes so critical because I think somebody has referred it's a garbage in, garbage out, right? If I am not giving a quality data to the models, you can expect an outcome, right? So that is the second dimension which is very critical. Third, obviously the model security in terms of your models are protected from attacks like denial of service attack or unauthorized access attack, that becomes quite critical, right? So that's the third dimension of it. Fourth dimension is as these models not independently acting, they are part of your AI applications, AI solutions. So how are your application security, software security is evolving to accommodate AI, right? In enterprise application development, currently if you look at, there are good discipline of a software development lifecycle, right? How AI has been embedded into that discipline, that's also very critical, right? And then within an enterprise, how do you protect an AI pipeline, right? Where you ingest, you source the data, then you clean the data, you pre-process the data, you create a feature store, and then you train the model, right? And then create a registry. So how do you protecting that entire AI pipeline, right? That also becomes quite critical. And then most importantly, how do you train your models, right? Do you carry out the practices of adversarial training, right? Where you are trying to basically simulate some attacks and then seeing the robustness or resilience of the model, right? So these are some of the dimensions what we think is quite critical if you have to have a really secure AI. Now from enterprise AI security assurance perspective, this is a framework what we promote as part of adoption. So if you look at it, starts from a governance, right? You are setting up a AI security governance. As part of that, you are setting up a AI security strategy, AI security policy, and processes required to govern the AI within an enterprise. Second thing is, I think, again, overlook your software engineering practices, right? Which is basically it's all your release management, change management, version control. Those practices are equally important where AI aspect has to be looked at, right? Mostly, again, overlooked. The third aspect is the entire your life cycle of AI, right? Where it starts from sourcing the data and then you are curating the data, designing the model, operating that model, and making sure all the feedback loop goes into correcting the model, right? Across all that, what kind of security guardrails you need to have in place, right? And we just sort of use the NIST framework for it, which I'm sure you would be aware about. So across your identify, protect, detect, respond, recover, you need to have those security guardrails adapted across your AI lifecycle, right? It becomes quite critical, right? And then obviously have a cyber hygiene discipline, which is like your identifying your assets, identifying your data, calibrating that data, and making sure the practices like patch management and all that is put in place, right? Now comes the data, right? I'm sure I think everybody would agree data is the training fuel, right? If your data is not good data, if it is, and now because of a GenAI, earlier your supervised or your semi-supervised model at least have a structured data where you have a better control, right? But with the GenAI now it's all unstructured, right? So quality of the data becomes very important, right? It's a training fuel for your all models, right? The quality in terms of making sure the data is free of the noise, data is errorless, there is basically predictable outcome which is expected if there is a clean data. Eventually, otherwise, then it leads to an hallucination errors, right? Your outcome could be a hallucinated outcome or it could be a biased outcome, right? So data quality plays a very critical role. Third one is the data governance, where the enterprises, as part of big data or data analytics, do have the discipline of a data governance, but it needs to be extended for AI as well, right? Where identifying your data inventory within your enterprise, then calibrating that data from a structured and unstructured data perspective, then basically labeling that data, right? Once you can do that and if that foundation is ready, then I think training the model becomes quite easy. But we don't live in an ideal world, right? Where you will have basically maybe an LLM where you have to train on maybe some images, some text and all that. How do you calibrate that data? It becomes very, very difficult, right? And then augmenting the data to make sure the outcomes are predictable and there is less probability of hallucination, right? So that becomes another basically a tenant of making sure the sound data practice. And then data privacy, right? I think morning there were cases about healthcare data, right? Now PHI or EMR data becomes so critical, right? From a sensitivity and confidentiality perspective, right? If you are feeding the data as is into a model, the model will get trained and that model will become public, right? Your healthcare related data may become public, right? So you have to make sure you are upholding the data privacy. There are regulations now, even in India, the TPD and all that is mandating that now. And I think data security becomes another important thing, right? Where there has to be appropriate data protection for sensitivity of the data. You have to make sure it is encrypted, it is masked, it is anonymized before it goes to the model, right? And this is what we basically propose. It has to be a data-centric protection to make sure whatever data going into an AI, there is a basically a data is defending itself or data is describing itself. We call it as a self-defending or self-describing data, right? So across the life cycle, if you look at when you are sourcing the data and preparing the data at the time of pre-processing, what kind of discipline needs to be taken care, right? You have to clean the data, remove the noise, right? Then also make sure if there is a possibility to classify that data and label that data before it actually goes into the model, right? Before it goes for a training. Then when you are storing a data, I'm sure you would understand the feature engineering and feature store where you are storing your data to train the model. How do you protect the data there? Because if you don't have a right access control in place, right identity or privilege access management in place, people can unauthorized access is a possibility, right? So making sure there is a right role-based access control, there is a sensitivity, appropriate protection, be it encryption, be it masking in that feature store becomes quite critical, right? At the center, you need to have that centralized data governance practices in place. And when you are designing a model, because that is where your secure by design and privacy by design, those principles need to come, right? So you have to make sure you are considering those principles as part of designing a model and making sure all the practices of your secure software development are replicated to your AI development as well as the ML development model, right? And when you are training a model, right, what is important is you have to basically extend your adversarial training part when you are training, right? You have to basically have a dummy data fed in to see the outcome, to see the resilience of the data, and also carry out a red teaming activity, right? Red teaming is eventually you are acting as a attacker and trying to simulate the attack and making sure whether model is responding it appropriately or not, whether it is resilient or not. So that discipline has to come in, right? And in model operations, you need to have an ability to continuously monitor, right? Because your current conventional capability to monitor is mostly for enterprise IT systems. It is not for specific adversarial attacks which are there on a AI and ML, right? So you need to have that incremental capability during ML operations so that you understand those patterns and you continuously to monitor and respond to those attacks. Right? And finally, I think when you are doing a reinforcement learning and bringing a human into a feedback, make sure there is the right access control in place and the right input goes, right? So this is how you have to make sure when you are feeding a data into the model, because data becomes quite critical asset beyond your application and model. If you apply this discipline along with that enterprise AI security discipline which I spoken about, you would have probably more responsible AI coming out, right? Predictable AI coming out, less probability of hallucination, bias, right? These are some of the technologies which have been leveraged to enforce these controls. I will not go through it, but most importantly, I think the privacy enhancement technologies, right, which are very critical to make sure when you are training a model, you are masking it, you are anonymizing that data so that the integrity or the referential integrity of the data is not lost. You can still train the data and have an outcome coming in, right? So privacy enhancement technology is going to play a key role into your training the data sets beyond, I think, traditional your enterprise IT controls. The second aspect, last slide from my side, how AI can be used for cyber. These are some of the use cases. We are using it for enterprises. We are using it for making sure there is an accelerated threat investigation, threat detection. From a security operations perspective, we are leveraging it to accelerate the incident response, right? When we get any incident, to do a triaging, to do an analysis and all that, it is all manual effort. We are basically leveraging our knowledge base and training the model to make sure that model has been trained and it has been assisted to our security teams to accelerate that investigation. There are other use cases also. For example, on risk and compliance side, now there is a European Union AI Act which has come, right? And people are trying to figure out what are the implications, what are the obligations, how generative AI can be used for it, right? So we are working on some of the models which can be basically trained on this compliance, and it becomes basically a compliance co-pilot, right? Where it can advise various risk and compliance professionals to advise on various obligations and how the risk needs to be mitigated, right? So there are various possibilities. We are also working to create some of the offensive use cases because attackers started using it. So how can we defend those, right? So we started leveraging AI to look at the patterns, the behavioral patterns, and because if you look at today, some of the malwares already are having the AI in place where they are trying to evade all your detection capabilities, right? How can you leverage for yourself and make sure those evasion has been detected and you are ahead of them, right? So those kind of things we are trying to do so that AI power is being used for a cyber as well, right? Beyond defending AI, right? So that's how I will summarize it. I think cybersecurity plays a key role if AI has to be successful. You have to make sure the fundamentals of cybersecurity has been extended to an AI discipline, including security assurance. Making sure the data discipline, the data management discipline being extended. Your model security becomes quite critical, and your other cyber hygiene, which I have spoken about, having asset inventory, having role-based access control, I think those are the cornerstone for AI success. So that's pretty much I have to share. It's quite exciting when we talk to enterprises. But obviously, I think there is a lot of inhibition to adapt it today because it is still evolving, right? And that is where, if I have to really call it, most of the people are going from idea to lab. The practice is still needs to evolve, right? It will take some time. The successes will depend upon, I think, the outcome and these guardrails. Once those guardrails are defined, and that's where I think all the regulations now, European Union has released that, US has some specific guidance. I'm sure India will also follow. I think once all these come together, there will be a greater AI adoption. So that's all from my side. Any questions? I'll be happy to.
Thank you, sir, for giving us the industry perspective. I request Professor Manoj to felicitate a speaker.
Thanks and welcome everyone. In fact, most of what I need to say has already been said, but they can give a slightly different perspective. So just a very high level talk here. So we are living in a digital age, in fact many digital ages in a sense. So had computers for a long time now, it's the century you could say. And of course, and another, thing that has happened over time is so since let's say mid-60s, internet has been there, but it's only in the 90s or wide web has come up, and that has also changed what our digital age has been. And one of the things that another piece of technology that has happened is cryptography. So I'm a cryptographer, so I'm going to put that as another major technology that has happened. And of course, cryptography has been there forever since ancient times, but it's only in the early 80s or late 70s, you could say, that something major happened. Public key cryptography was invented, and that changed a lot of things. And by the time internet was coming up, this cryptography was already there. So all the communication that is going to happen over the internet, could be done securely. And we didn't notice a revolution because cryptography is already there. Then internet came along. The last piece of technology I want to is AI, of course. That's the theme of this workshop. Could you go back? Oh, no, go back. And AI relatively is a new kid in the block. Of course, AI again has been around for a long time, right? Machine learning, I could say in a sense, computers or even conceptually before that, people have had notions of AI. But it's again only about, 50 or 20 years back that deep learning revolutionized what we think of as AI today. So we live in this world where, we have very efficient computers, we take internet for granted, everything is connected up, we have cryptography to help with secure communication, and now there's AI, and we need to go back and take another look at if everything is fine or what needs to be done. Okay, so I just wanted to again everything that has already been said. But kind of maybe putting it slicing it up slightly differently. I want to talk in terms of different aspects of AI intersecting with information security. So AI with the adversary, AI with the defender. So by the way, when I say adversary, I have a certain notion of attacking a system. A lot of military folks here. So you might find yourself being on the side of what I'm calling the adversary, right? So various kinds of offensive strategies, and the defensive. So AI, using AI for the defense, and then AI as a resource that we are attacking or defending. So these are kind of a few different aspects of AI and security that point out. Again, nothing deep in it. It's all probably very common sense things you would already get. But let me go over it anyway. So I'll start with AI as adversary, and I'm just using my words, but maybe a very broad kind of adversarial scenario for which AI has been very helpful in the sense of helps adversary is various sorts of scams. Right? So, of course, we have always had scams going on, phishing, and that sort of stuff. But with AI, it has kind of taken on a different life. And a broad class of these kind of scams involve synthetic media. Synthetic media is what you would think of as deep fakes, right? So creating various kinds of media which look real, but actually they are generated. So generated AI. Again, we have had Photoshop forever, but now you can do videos, right, and voice. And earlier, you would have needed a Hollywood studio to produce that kind of realistic video, computer-generated imagery. Now anybody can just download the software, create customized synthetic video. And this, I would say, is a very terrifying situation, right? When you talk to somebody on the phone, you don't know if you're talking to a real person or a fake person. You sit here, person, or somebody calls you on the chats with you, you don't know if they're a real person or a fake person. Even if you see a video, you don't know if it's real or fake. And with time, this is going to get worse, right? It'll be real time. Somebody calls you up on WhatsApp and you're talking to them. person on the other side, the real-time video that you're seeing, who is responding to your questions, may not be a real person. And that's a terrifying situation, and it's a stuff of science fiction. And this has been the stuff of science fiction for a long time. So this apparently is a novel from 1901, so turn of the last century, and it's probably self-explanatory. The cover page, the lady automaton. So that lady there is not supposed to be a lady; it's a robot. It was before the term robots were invented, and sure enough, the notion of that automation is very much like what you would think of as AI could help with. So here's what that automation could do. Words are spoken into the ear of my automaton. So this is the inventor describing this invention. Passing through the ear, these words enter a machine you would call the phonograph and set in motion various processes, which in a very short time produce the words constituting the proper answer. So this lady can respond to you in real time, and people think of her as a real person. Right? So thankfully, we are not there yet. You don't have to worry about automating that look like people. But that's probably where it will head eventually. So that's kind of just to put a thought in your head, that this is of course science fiction stuff right now, but something to bear in mind. But coming back to today, another real problem with AI is breach of privacy, right? All sorts of attacks on your privacy. So, you could use AI to now make inferences which are hard to make from this sea of data, all the signals, all the breadcrumbs you are leaving aside in your digital life. They can be collected together, and inferences can be made which are earlier hard to make. AI models can be made about not just you, but entire groups of people, and oftentimes that's also not quite a good model for you, right? Because if your adversary is doing this, you don't care. That's not the biggest concern. Let's go back. So if some of these models are inaccurate, and here it's not so much the concern is not so much that the adversary is doing, but this could be what the government could be doing, government agencies could be doing, institutions could be doing. They're using AI to make judgments about you, whether you should get a job or not, whether you should be put in jail or not, things like that. And these models are essentially stereotypes, right? May or may not be a good fit for any individual. It's based on the data collected about a lot of people. So that's another thing to be wary about AI. And finally, surveillance. Again, this is an offensive strategy. It could be done by, it could be legal, it could be illegal, it could be ethical, it could be unethical. And there's a lot more that you can do with AI. So much so that now there is a AI global surveillance index that people have that has been created about which countries are using what kind of surveillance that is relying on AI technology, in particular things like face recognition. Okay, one maybe somewhat different question than you might think of as an impact of AI is the question of whether AI can be used to break cryptography. So now cryptography is based on computationally hard problems, and in some sense AI cannot help, because AI is also just computation. So no matter how clever it is, at the end of the day, if no computation could break some problem, AI cannot break that problem either. So in that sense, AI is not going to hurt. However, the particular constructions we are using today, the cryptographic constructions we are using today, why do we think they are actually computationally hard problems? The only reason we think they are computationally hard say block ciphers and so forth, is because a lot of experts have worked at breaking them, and today's techniques so far have not managed to break them. So block ciphers that get standardized are the ones that win a competition where everybody failed to break that block cipher. And then we think, okay, this must be one of those hard problems for which there doesn't exist any efficient computation. But unfortunately, we don't know. We can't be sure. And the kind of mathematics that's out there has not come up to the point where we can actually prove that this particular problem is hard. So we just go by this competition and not being able to break it. And the question is, could AI and other techniques help with breaking these things? In some sense, it's not a bad thing, right? It's just more expertise. If you bring to bear more expertise, then we will improve our search for what is actually computationally hard. But the trouble is, if somebody finds it and the rest of the world doesn't find it, then it's a problem. As of now, though, I should say there is no evidence that AI is helping any more than what cryptography experts are managed to do. So now it's a very niche topic where people are trying to see how much further we can go using AI. And the answer so far is probably not much. And finally, hacking. Again, this refers to a broad spectrum of things. People breaking into computer systems, and how can AI help this adversary? Well, we could use AI techniques to figure out what kind of operating system is there. We can try to infer vulnerabilities in the system based on all the data you collected or the previous incidents that you're aware of. You could try to infer vulnerabilities. But probably a more kind of dramatic thing is AI could help with creating software, which is malware, and it could be customized for your use cases. So ChatGPT can write code for you, right? Apparently, there's something called Fraud GPT you can buy on the darknet. I don't know if you want to pay money and get trusting that you'll get this software. If the person who's selling it is doing fraud, I wouldn't want to rely on that. But apparently, that's what they advertise. There's something called Fraud GPT. And the effect of that is, so there has been this notion of script kiddies, right? You don't need a lot of expertise to be a hacker. You can just search the internet, download scripts and run them. There'll be instructions, there'll be a recipe what to do, and you can break into systems which have certain vulnerabilities, right? So that is script kiddies. Now, LLMs take it to the next level. Because you could have you could have real-time advisor there telling you what to do. Because ChatGPT will refuse to tell you things, and the things they're actually trying to break into systems, you could trick it into doing it. But this Fraud GPT is supposed to help you with breaking into things, giving you code that you could use to. So it's not a script that you download, but it's a script that is generated for you by this software. Okay, so that's another new scenario we have. Okay, moving on to AI as a defender, I'll be very brief now. It has been something that we've been doing for a long time, even before deep learning and so forth came along. ML techniques are well suited for detecting anomalies, so anomalous behavior in the network, more communication going on and so forth, and helping with responses. What software to shut down or right, like how to respond to a particular anomaly that you detect. So these problems are always a good fit for AML, and better AI will help you do it better. And in this sense, detecting vulnerabilities, checking if your system might be susceptible to certain attacks. This is some of the tools that hackers are also using. So defenders and attackers could both benefit from better AI on this earth. One point, I have this kind of a long list of AI adversaries, threats. For the defender, I have kind of been brief. And one reason is that not every attack by an AI adversary, AI enhanced adversary, has to be from an AI enhanced defender. Okay, the defender doesn't need to, AI may not be the thing to use to defend against an AI adversary. So to give an example, so we have privacy breaches, and also in the next slide I'll talk about the privacy in the AI models. And to protect against that, it's not AI that you would want to use, it's some cryptographic tools that you might want to use. Might be differential privacy or other tools that you might, statistical tools that you might want to use. And also, it's policy that you would want to use, right? And legal frameworks that you would want to use to protect against some of these privacy. And the last thing I want to talk about is AI resources, the security of AI resources. So, this is what in the previous talk talked in very detail: the privacy of the data, privacy of the models that are created, and the integrity of the data. Right? There are issues like data poisoning, biases in the data, that, so that the quality of the data protect. Adversarial ML is a broad class and includes some of these things like data poisoning, which talks about exploiting the fragile nature of ML models, like kind of crafting your inputs in a certain way that the ML model gives you wrong answers. So trying to protect against the risk of ML. And finally, maybe not so often talked about, is just, forget adversarial errors. There are just errors in AI ML, right? So there's a certain probability of errors. The accuracy is only 99% or whatever, right? There's about 1% of error. And if you're using AI for critical scenarios, then it could be a big problem. That 1% error could be critical. Okay, so that's another thing to worry about in terms of protecting systems that use AI. Okay, so, and in that context, even if there is no attack, your AI system has done some damage, has killed somebody because it drove a car into a train or something, who is accountable, right? So if a human being does that, you can punish them or you can prosecute them. When an AI system does that, who is accountable? There are many people who went into building it, many people are proving it, and so that's another legal question. Okay, so to wrap up, so there are all these questions, and just to make a plug for IITB Trust Lab, this co-sponsoring event. This kind of intersection of AI and trust is something of great interest to us. In particular, the next slide, we are, we have just a plug for our course that Professor Thomas is offering in June, 1 week on hands-on web security. If anybody is interested, feel free to sign up. It's on web security, and you can see all those different modules in a very standard web fundamentals, server-side attacks, client-side attacks. But then, there's no escaping this last special topics. We do need to talk about LLM attacks, right? Used nowadays to attack web servers. So that's a chance to learn about those things in more depth. Okay, thanks.
Thank you, Professor Manoj. I call upon Professor Mondal for his talk.
Okay. Good afternoon, everyone, and thanks for staying awake after the heavy lunch. So in this talk, I will be continuing the talk by Manoj and Prashant and talk about understanding changes in privacy and security landscape in India with not only AI but with new technologies, because they have some similarity as we'll talk about. Before we dive in, who am I? I'm Mainack. I work in human factors in security and privacy, and I am an assistant professor in IIT Kharagpur. The QR code is to my webpage, or you can just search my name if you want to know more about my work. And I basically work with this motivation. You see, one side you have your whole technologies, encryption, the firewalls and everything, and other side you have Dave, who is a human error. Or rather, you have human behavior, because as Manoj told in the previous talk, it might be just humans are doing some errors, some behaviors that can create some privacy and security problems. So essentially what I do is data-driven and empirical understanding of users' privacy and security behaviors. And I build systems which will align with user expectation, because users are somewhat the weakest link in the whole security chain, be it in AI-driven or not. How I do it? I generally start with acquiring user behavioral data. I use that data to model the users, and then using that understanding from the model, I try to build systems which sort of are usable, private, and secure. In one sentence, I basically do empirical data analysis and data-driven system design. And in this talk, I'll talk about how the requirements of managing privacy and security of users' data is changing due to new technologies. Now, what do we mean by new technologies? You see, like, I am here for the first session, and from that onwards, I'm hearing new tech, emerging tech, and so on. So, what do you mean by emerging tech? That's the arcane question, right? Now, it turns out that it is not really one definition, but I still would like to know, like, every one of us has some semantic meaning, some intrinsic idea about what new tech is. It turns out that in 2015, some people actually take out all those definitions and try to summarize them. And they came up with 5 characteristics which will characterize a new tech. And they are radical novelty, relatively fast growth, coherence, prominent impact, and uncertainty. The last one is, I think, most important to us, uncertainty and ambiguity about how that tech would behave. Some examples, aside from AI, of course. Any idea? Any tech that you feel they're emerging techs today? I'll go. Yeah, sure. UPI. Perfect, yes. So I actually put few. You see, blockchain, IoT, UPI, digital contact tracing are the same too, because it was rapid increase and everything, and then privacy, security, everything was pretty much messed up. AR, VR, self-driving car, big thing coming up. Now, one word is missing from here because I have a whole slide for that. So what I did was that I took the NIT's this year's call about how NIT's, what projects are they funding in the civilian space, and I created a word cloud. The biggest one is AI, right? And this call was about emerging technologies, not specifically for AI. But AI is basically have a special place in emerging tech. However, AI actually behaves like emerging tech when they create privacy and security problems. So how? Let's understand how the new tech or emerging tech actually gets adapted. This is not new. Don Norman, 1988 onwards, is talking about this process. You see, this is how it works. First, a new technology just comes up, and then users perceive their affordance, what the new tech can do. Okay, based on that, the users do some sort of calculation based on their security and privacy risk and the system benefit, and based on this understanding, this trade-off between the good and bad parts, they negotiate where that technology can and cannot be used. That's the contextualization. And finally, the rules of usage stabilizes. I am not going to use like really heavyweight softwares for my class projects. You are possibly not going to use AK-47 for whatever can be done by negotiation. So essentially, that's the time rules of usage of a particular tech. But this creates problem. How? Well, you see that calculating the security and privacy risk is very subjective. And that can only be perfect when you have a good idea about what the security and privacy risks are and the system benefits are. Now, what if there is an incorrect perception about the system? What if you don't know what AI can do, what the errors can do? Suddenly, you have an imperfect understanding of the world, and that actually gets to incorrect usage rules. And this incorrect usage rules essentially go for harm. I'll talk about those harms. But this is a very simple mental model that people came up with, which is very applicable to almost all emerging tech. And these harms can be financial, mental, or even physical. Self-driving cars. You just believe that it doesn't need to be manned, or you don't really need any human intervention, and suddenly you're just going to kill people left and right. Might or might not be possible. Okay, so because before AI came, as we got the answer, UPI was one of the emerging tech that actually sort of changed our country, for better or for worse, but it changed us, right? So this is a case study from my own work. I wanted to show you how emerging tech actually gives rise to new privacy and security requirements and how we can help. So the UPI is popular. I guess we believe that, right? This is data taken last night that 19.6 lakh crore rupees transaction is done in April 24. 1 month, right? That's huge. And these are basically the popular UPI apps. Paytm has really low market share, but it is gaining. But in any case, these are the main ones, right? So they're important and they're popular with me, I guess, all of you. Now, you see, unfortunately, it is also very popular with fraudsters. Financial frauds, top cybercrime in India, UPI e-banking most targeted. In fact, 50% of all financial frauds reported today are due to UPI. So it is really popular for users like us and also for the fraudsters. So when we started understanding that what is the problem with UPI, we actually saw the protocol is actually fairly solid. In fact, there is a work in using security which tried to improve the protocol. NPCI incorporated those changes and the protocol itself is solid. However, still social engineering, phishing, as Manoj was saying, that kind of attacks are on the rise. However, problematically, there is no idea about what those different types of attacks are. So what we did was first we created an attack taxonomy. We went to Reddit, we went to Google, we tried to see what people are talking about again and again, what type of UPI frauds are they getting subjected to. Collected the data, did a semi-automated manual analysis with some NLP, some AI, some human intervention. But finally, we came up with these 4 fraud types. That's a nice story actually. The first one was request money fraud, where the attacker is requesting money with fake offers. Second one is attacker provided QR, where the attacker is providing a QR which has a different amount than was agreed upon. Third one was confusing users by tricking them to click on a link and getting the money. And finally is deception, posing as a legitimate business. These 4 are the most common strategies by UPI fraudsters. Using these 4 types of frauds, we wanted to know that how much users are susceptible to these frauds, and more specifically with this new tech, what are their decision-making processes? What we did was that we created infrastructure, a framework which looks like UPI. Okay, this is the right side. I'm just showing a screenshot of our infrastructure, and it actually is a mock UPI app, has lots of tracking functionalities to know what the user is doing and so on. And then we ask the user, you know what? Here's a scenario. Someone is asking you to click on the link in this app. Are you going to do it? Why do you want to do it? And why, if not, why not? Right? So we collected the data. We collected the data from 20 participants, multiple different scenarios, around 6 to 10 from each. And then we use qualitative coding method to have in-depth understanding to know that what are the decision-making process in front of this new technology. We figured out that they have a 3-step decision-making process for UPI. First, whenever a new request comes, users do a security assessment via checking that whether there is any flag, any red flag that transaction is raising, and also they corroborate it with their own digital knowledge. Well, if there is something suspicious, then they go to the next stage. They check if the requester is trustworthy or not. Well, if there is something suspicious, then they go to the third stage, greed. They actually check how much they want that money that the attacker is promising them. So with that three-stage process, we ask the users that, so what do you need to help this process? We actually find out 4 things that users actually told. They want support to identify fraudulent transaction. They want to know if there is an anomaly. They wanted to know if they wanted to get some contextual notification. That is, if it is a really big amount, then possibly you want to click 5 times. The users told that they want education because most of them don't really know how fraud happened. And finally, they wanted some way from the system, from the government, or from whatsoever to establish some trust from the deceiver, telling that, that's a good party or bad. Coming back to this tech adoption process, this whole work is revolving in one step, calculating the security and privacy risk and system benefit. And what we find is that users want support for doing this calculating security and privacy risk and system benefit. In fact, they want support about education, finding anomalous transactions, and establishing the trust of receiver. At least in the last 2, AI can help, that we know. Now, taking this analogy, I'll quickly just go over how that translates to AI, or rather, responsible AI, because that is where it is going. If you look into the calculated security and privacy risk or system benefit, there is already a taxonomy of privacy and security risk for AI, and that sort of supersedes and includes the fantastic previous 2 talks. This work from KAI 2024 by Souvik Das from CMU, they actually looked over all the different types of AI incidents and categorized them into 12 different security and privacy harms that the next-gen solutions, privacy and security solutions, might need to protect against. The first one is surveillance, and they also identify that these risks, some new, but others are just exacerbated. AI made it much, much, much worse. Surveillance is one of those risks which actually is exacerbated, and the example is predictive policing. Then you have identification. AI is actually a new risk of identification. It finds correlations that was previously not in the data. Then aggregation is a new risk by AI. For example, NDAs use the AI to predict the risk of someone committing a crime, predictive policing, which might be wrong and might actually be pretty detrimental to one's life. Another new risk is inferring emotional state from physical image that AI can do. For example, GADAR, it's a semi-malicious app which will try to detect whether someone is homosexual based on their physical appearance. Sounds discriminatory? It is. But AI is used for that. Well, secondary use is an exaggerated risk by AI where the data set was created, for example, for making the facial recognition better, more fair, and the same thing was used for more accurate facial recognition. There are other examples which actually came from not so benign. They actually came from medical field. Some data was given to do something, and then someone used that data to do something really, really different. Bad, really bad. Then there are 4 or 5 more risks. So one is failure to tell users how data is used. This risk is exacerbated because no one understands now how AI is used, what the data is, and how it is stored. The leakage of personal data is not understood at all. Like chatbot leaks personal data, which is a problem today, and that's why I know at least one industry, a friend of mine told they don't use chatbot, they don't train their internal data with chatbots, because no one knows which team's data is getting leaked to which team. Exposure is another risk, which is a new risk. Exposure basically means like creating deepfakes, disinformation, as Manoj was talking about. Distortion is yet another new risk, and finally, improperly sharing data. Like NHS shared 1.6 million patients' data with some third party who reshared it with someone else, and NHS has no idea. So overall, what I want to actually take away is that these risks are real, and AI created or exacerbated these risks. Just 1 minute. And they are not abstract. These are screenshot taken last night because I am in Mumbai. They actually show me Mumbai results. So Kokila and Dhirubhai Ambani Hospital apparently used Rapid AI. Then I dug in, what is Rapid AI? It's a US-based company, and they are using it as an API. No one knows where your patient data is going. Well, what about other hospitals? Apollo Hospital, by 2022, they have an automated AI solution, and no one knows where the data is going, how it is stored, how it is used. So essentially, what is the way forward? Differential privacy, data privacy auditing, ethics check, all of these are great. The problem is that none of them are directly applicable, and it is not really possible for companies to use them as it is. They need to be customized. Who would customize them? The companies? They don't really have the fund. So ultimately, I will end on this note because that will also give the segue to the panel. Can we really create actionable, community-driven AI-specific guidance and toolkits? Because guidance on its own is not helping. And toolkits for responsible AI deployment while mitigating the security and privacy risks that are already identified, even after within 3 years of deployment. Thank you.
Thank you, sir. We'll now move on to the panel discussion. I request Professor Manjesh, Professor Manoj, Professor Mondal, Professor Kazi, and Mr. Deo to join us on stage.
Good afternoon, everyone. So welcome to this panel discussion. I just want to do a brief about the reason we kept this panel discussion pick up the talk. We felt it like after a speaker gives a talk, maybe there will be some question answers. Instead of question answers, taking each speaker's question answers separately, maybe we can club them so that at the end there will be some question answers, maybe some additional point of discussion like that. So later, like if you have any questions that you have to Professor Manoj or Professor Mondal, please do ask them. And also Professor Kazi and CTO will also add some more points. Okay, now we thought the topic that we are going to discuss is securing enterprise data and digital identity. As you know, now has been talked about security and privacy are very important. And as we are advancing in technology, it's only becoming more and more complicated. So with that, with the focus of AI, a lot of things are happening, emerging rapidly in the AI. So I want, as an opening remarks, I request each of the panelists give their opinion about how this AI is helping us, especially in securing enterprise data and the digital identity. Some of them, they have made already some comments on that. If they have any additional points on that, I request each of them to add.
Thanks, Manjesh. So I think I had my chance to talk already, but I'll just briefly mention. I think maybe the biggest threat, at least to my mind, is the human factor, right? Like using what I mentioned as scams, using AI to fool people rather than fool machines. Right? And I'll add to also what one of the things that Mainack was saying. The problem is because the technology is new. That's why people are having difficulty using it, right? And because the question is, how long would it take before these things would stop being so new? And what way could people get used to it? So one thing, for example, is things like deep fakes. Or even WhatsApp message forwards for that matter. There was a time, or maybe it's still not past that time, where people would get something on WhatsApp and they would trust it. But over time, people learn that okay,
pretty much everything you're getting as forwards are suspect. Right? They're not being trusted. And similarly, you would see whatever, synthetic media, and there would come a time where you would say, okay, anything you see is, online, you cannot trust it, right? And then the effectiveness of that kind of attacks would go down is what one would get.
Yeah, thank you. So I would like to drag the attention to slightly a different use case of AI being used in the cybersecurity, and that's mainly from the critical infrastructure point of view. Because whenever we talk about cybersecurity, we mainly talk about its non-kinetic manifestation. So this can be misinformation, disinformation, or impacting some kind of confidentiality or integrity of the data. But recently, a couple of incidents have shown the capacity of the cyber incident to in fact infiltrate more towards kinetic nature. And if I talk about or take the names of those incidences, many of you may be aware. One was the Stuxnet, very well known, where there was an incident, cyber incident impacting uranium enrichment plant in the Iran. Another one was at the Ukraine Black Energy 3 for the Discom utility within the Ukraine. So a lot of such kind of cyber attacks which are currently happening on critical infrastructure. And the reason they are becoming more and more serious because its implication on the national security. So when we talk about the enterprise security and AI applications of enterprise security, what also needs to be considered, because when we talk about enterprise, generally that is being referred as IT security. Beneath that enterprise or IT security comes something called as OT security or operational technology security, where you may be having some kind of physical process necessary for the critical infrastructure getting sabotaged by such kind of cyber attacks. So earlier, people were not having much of the use cases of AI in security of this IT and OT integration, which people call as a digital transformation in some other vocabulary. So generally, what happens in case of cyber attacks on this OT is that the hacker or the adversary will be spending a lot of time on recon phase and lateral movement. Because generally what happens is there will be an air gap between IT and OT, and one has to work really hard to find out which particular machine of enterprise IT is talking to the OT infrastructure. So that phase is something which can be definitely secured by using AI, because that is where you would be mainly interested in knowing user and entity behavior analytics, or the tools which are coming up like SOC, SIEM and SOAR type of solutions, where huge amount of AI deployment or use cases are being considered. So I think one of the direction in which the AI might be leveraged for cybersecurity is OT security or critical infrastructure security, and that is emerging area, I feel, as in terms of the AI deployment. Now, when we talk about the digital transformation or IoT, then definitely this would also be creating a lot of use cases for identity management and other issues to come forward. So I think this is a very vibrant area and upcoming area for creating a lot of use cases for AI in cybersecurity. So with this, I conclude my opening remarks.
Professor Mondal.
Thank you. I would like to agree with my fellow panel members totally. However, with a caveat, which is that I think for AI as emerging tech, for any emerging tech, actually the primary drift for the society is to use it for all the reasons, everything. And then after a bit of harm and foul, we started to know that which way is applicable, where it is not. For example, in our previous generation, my parents used to trust the newspaper. After that, they used to trust whatever is on TV. After that, in our generation, we used to trust whatever is on WhatsApp. And now we don't really trust anything except for AI. So things actually change. It's not that they stopped trusting TV. They actually stopped trusting whatever is shown on TV. They started trusting specific programs. They know the context. that contextualization is something which is a great challenge for enterprise security and using AI in enterprise security, because not all technologies, like there is a adage in systems research, everything, all the questions can be answered with one answer. It depends. Similarly, where AI will be a game changer, but where it will change the game, that needs to be very carefully fleshed out and understood. So that is what my take is. How it will be done? Essentially by trial and error. There is no easy way of doing it. However, logging it, understanding it, and reacting to it will be the key to use AI effectively in both critical and non-critical infrastructure.
Thank you. I think my fellow panelists has explained it can be used for enterprise, for OT, and for other areas, right? See, my take is, if you look at today, there are inhibitions on innovation where there is no appropriate data availability, right? Can AI be used to generate a data? Generative AI, maybe yes, right? Synthetic data you can generate, and probably you can have that innovation, because today, if you look at morning also, I think there was a question, there is no data availability, right, where you can train a model. Can AI help there? Probably yes, right? But obviously you'll have to see the quality of the data and all that, right? So in my view, I think how AI can help, one is to secure enterprise data. I think there are use cases across the life cycle of the data, right? See, few challenges what you see in your data analytics or your big data projects. One is your data is not sort of managed well, right? You have so much data in enterprise, right? You don't have visibility, you don't have catalog of the data, you don't know who is holding that data, right? Can AI help there? Yes, potentially, right? You can probably have AI engine to scan your entire enterprise to identify the data, and probably based on, if the model is trained to identify those patterns, it can probably label or tag the data as well, right? It can solve that problem, right? Once you identify that data, classify that data, then it goes basically into sharing the data, right? Which is again a challenge, because data sharing becomes a challenge. Can AI help there? Potentially yes, right? Because sharing, the inhibition of sharing a data is because it's a confidential, sensitive data. Can you protect the confidentiality, integrity with the AI? Potentially yes, right? So in my view, I think AI can solve some of these problems of a data life cycle, and I think it can largely help not only for LLMs or your AI use cases, but for larger your big data analytics problem as well. So that's my viewpoint. Yeah.
Thank you all for this opening remarks. I want to come in the reverse order now, especially Mr. Deo, you talked about using AI in the cybersecurity, especially about incidents, handling the incidents responses. Like the way I see is like when an incident response happens, suppose let's say you have a proper system to collect the logs and all, and now you have to go and analyze what went wrong. But usually these logs are huge, and when you have an AI model, I don't know, like, is this AI model has to be trained particularly for your enterprise, or like there will be some pre-trained model which I can use here? And also, this AI models, we can't expect them to be 100% accurate. There will be some false alarm. Like when you are searching in a huge data and there are likely to have some false alarm, how industry is trying to cope up this such problem? Do you know any particular use case, especially TCS is facing such issues?
No, so certainly I think, see, the investigation can be made only when their data is visible or your logs are visible, right? AI cannot go everywhere and start identifying that data, right? So the way enterprises are doing it, there are pre-trained models, right? For example, Microsoft has released the Microsoft Security Copilot, right? Which is a pre-trained model on huge data what they learned over the year, right? So that data has basically model has understanding to make a educated guess which is normal pattern, abnormal pattern, right? But as I think the threats are evolving very dynamic, you need to have a continuous probe and monitoring of this data, right? And that is where there are some innovative technologies which are coming in, which is called as a machine learning detection and response technology, right? Which basically are probing for adversarial attacks. Right now, these adversarial attacks have some specific signatures, right? If you follow Maitre attack framework, right? As per that framework, there are specific signatures, tactics, techniques, and procedures, right? So basically, these MLDR platforms do have those signatures where it can even detect this kind of a new attack. So it's a combination of pre-trained model on known patterns and then this near-time MLDR platform, which is helping to basically detect an attack. The way we as a TCS doing is, one is obviously leveraging what is commercially available, like of Microsoft or Google. But we are also basically contextualizing some of these models for enterprise use cases, because enterprises would have their own data patterns and all that. So we go and basically pick up a foundational model and train it for a specific context of an enterprise. And that's how we understand those incremental attacks on that enterprise. So that's how we are handling it. Yeah.
Okay, thanks. Like especially when you talk about this microframe attacks and all that, yes, there are a lot of tactic techniques they have defined, but these tactic techniques could be not just adversarial, it could be normal. In your normal operations, you will be seeing them. Then how to separate them from the real attacks? So that becomes like you are searching for like a needle in a ocean. Like, that kind of searching space, huge. So I was just wondering, like, one example you gave, Microsoft has already released some LLM. Okay, yeah, that's a good information. Yeah, thank you very much. And I will come back to Professor Mondal. Mondal, yeah, the point you raised about TV to WhatsApp, right? Like, I was wondering, is it that with this is also actually not, this is just not of the privacy issue, it is also like dividing people. Like, for example, TV, as you said, right? We start only seeing the channels which are like, maybe I will stop seeing the channels I don't like. Now WhatsApp, I will remain in the groups where similar thoughts are there, and I will simply get out of the WhatsApp group where things I don't like. In that way, do you see any pattern emerging there, like these contents are curated in such a way that anyway that opinion manipulation is already happening? Do you see this getting exacerbated with this technology, especially using AI?
Totally, yes. Because, okay, two things. I'll make 3 points actually. The first one is, you're absolutely correct that when there is a choice of information that finally people make, they actually go forward to what we call filter bubble, right? It's not, digital divide is related, but still it is filter bubble, means that you're only, or echo chamber, right? Better to say, echo chambers, right? And that's the first point, that yes, people will ultimately go to echo chambers, sort of, but it is a little bit different than ideological echo chamber. It is more like you are fixing where you are getting your feed from, where you are getting your information from. And those might be from the similar kind of organizations that will make your ideas similar, but still they're trustworthy. That was the main idea that people generally go for, and that is how society actually functions. Now, the second point is, it would have been better if there is diverging and diverse opinions. That is called breaking the echo chamber. But it is problematic to go venture too much in it, specifically in the form of misinformation generated with AI. Because AI, as in the taxonomy that I have shown, AI is actually meant to generate specifically emotionally engineered content, right? And at scale. So you really don't want to pay someone 2 cents per post anymore. You just want to generate 200,000 posts in a day, which is meant to invoke specific emotions. So to that end, people will start identifying those actors pretty fast. Like during the 2017 election, US election, and the ensuing this propaganda war, people actually identifying that which platforms they would listen to. So that thing will anyways happen. Yes, it is echo chamber up to a certain extent, but it is also a way for people to protect themselves or protect their own ideology or whatever you can say. They can win either side of the spectrum. They can only feed on misinformation, they can only feed on good information. Most of us will be somewhere in the middle, but that is going to happen. However, the third point is that yes, AI-based misinformation is an issue, is a problem. and it is not only for normal people but also for enterprise security, which actually gets this data from different sources, which can be actually influenced by automated bots. So essentially, what AI actually makes, so there is this game, right? This adversarial games that security researchers actually devise and play. Essentially, that means that if you want to detect me, I'll try to evade you, and your every move will be a reaction to my own system. Right? So that is the third point. Is essentially that there are some cases where such a game would be useful. There are some cases, or it's still not useful. There are some cases such a game would be acceptable. Right? If you just missed, for example, one attack, it's fine. That's not many. For other cases, it might be like a critical infrastructure. It might be a big no-no, and there needs to be much stronger defenses and guardrails to be in place.
Yeah, thank you. So I want to come back to the critical infrastructure security you mentioned about. So a lot has been talked about IT security solutions. Like people have set up SOCs, logs, with all the set of tools you mentioned about SIEM, SOAR, EDR solution, ADR solution. But now, is this set of solutions is also good enough to secure your OT aspects? Or is there something like you have to go beyond? You made a remark about the AI. Is that like adding an AI component to the set of tools is good enough for something, even in terms of the visibility? Like a lot of things depends on what the logs we can collect and what is the visibility we have. And when we talk about the OT security, do you see any challenges? Like, because OT devices are also like very very specific devices, right? They may be running on some niche protocols. Getting a visibility may not be same as getting the visibility on the endpoint. So do you see any challenges, and especially the remark you made about AI, how it can play a role there?
Yeah, so indeed there are challenges. The first challenge is that OT devices would be having some kind of constraint about computation. Yeah. So they cannot have huge GPUs at their disposal, and they can do a lot of number crunching or other things which are otherwise required for AI. So that is the first limitation. The second limitation is about mission critical nature of OT yes. or critical infrastructure. So there are a lot of commercial solutions available which people call as intrusion detection system, which call themselves deploying AI tools at the back of their computation end. But at the end of the day, what happens is the quality of logs which get fed to those tools matters a lot. So there are efforts wherein log enrichment is being thought of by having a better quality logs being pushed to this intrusion detection system, and that would be trying to reduce the number of false positives. So the constraints which currently people are facing while deploying AI in critical infrastructure is because of the computation capability of OT system and the mission critical real-time applications of the critical infrastructure. So these two are the major hurdles. But if you see, since now these cyber attacks are increasing, a lot of database get generated. So if you talk about like IBM QRadar or ArcSight or those kind of solution provider, at their disposal they have huge database of IOCs, the indicators of compromise or bad IP addresses which may be reflecting some command and control center. So those can be leveraged so as to cut down the false positive. So there are indeed constraints, unlike enterprise or IT security where AI is now commonplace. For OT, probably it needs a little bit of maturity, and maybe over a period of time, we would see a lot of AI deployment happening in critical infrastructure as well. So currently what we are having right now is at the stage of intrusion detection system, and there are indeed some commercial solutions which are giving good results.
Okay. Sure. I see that like getting, as you pointed out, running some agents on these OT devices is itself is a difficult task because they have to respond in real time. Putting an agent there itself will take more of their resources. A lot of challenges. I'm not sure, like at least I have not come across any kind of agent one can put on these OT devices to collect these logs and all.
There are nowadays, like last 3 years or so, we are flooded with such kind of agents and devices in the world.
Okay.
So probably somebody would like to encash the sudden fear environment in critical infrastructure and push it across the solution. How far effective they are, people are yet to come to the reality.
Okay, Professor Manoj, again, I want to you to little bit comment on this quantum scale. Like you have been working on this cryptography, people say that all our current cryptography algorithms will become redundant once quantum things materialize. Where do you see this going? Like, is it going to severely affect in terms of the security and the privacy in the near future?
So let's start off to clarify. That's completely orthogonal to concerns like AI, but just talk about it. The short answer is nothing to be scared about. Right?
Okay.
I mean, of course, in theory, there are quantum computing algorithms which can break some of the most commonly used completely crypto systems. But in theory, again, we have other systems which can replace the current systems as and when quantum computing becomes available. Nowhere near being able to break cryptographic scale to be able to do cryptographic scale computation can be very experimental quantum computing that people are trying to achieve, where they're trying to get some sort of quantum supremacy is on very small scale. So nothing to be, from a user point of view, bothered about on the quantum side. But if I could comment on some of the questions asked here on the AI thing, it's unlike quantum, very real, right? And one of the concerns is, like you mentioned, things are getting deployed very quickly. And of course, the commercial, who is pushing these products, they have a commercial interest in getting them deployed quickly. But it's like, this is very, like, you're starting to, you just invented cement or concrete and you're trying to build skyscrapers, right? It's like, we don't know what all could go wrong. And it's not it's a premature technology. It's not ready for mission critical things. On the other hand, of course, it can do various things, right, to various extent. It's not reliable. That's all it can. Like I said, it can, of course, build some skyscrapers, but some of them might fall down. You don't really want to rely on that. The other thing about AI is that it's being a new technology. Like people, believe in it, or people think it's magic which can solve problems, and they trust it even if it's not trustworthy. And I say people, it could be very educated people. It could be judges or doctors or people who are maybe not familiar with the computer science plumbing that's under the hood, but who see that AI is being promoted by big companies, it's being used by government, it's being used in various places. It appears completely trustworthy. Whereas and it's very opaque also. It doesn't. So so there are these examples of in the US, the justice system using AI to predict recidivism, the probability that a person will go back to committing crimes, so to decide whether to let them free or put them in jail. And a judge sitting there sees a number saying there's a probability. There's nothing is explainable. Like, where did that number come from? And what are the biases in the data that would have generated it? So this is a major issue for trustworthiness of AI. That things are not explained out, and it's a big, big question. It's a well-studied question, technical question for AI scientists to, build an explainability into AI systems, but it is possible.
I see like a lot of terms like responsive AI and what is that? Fairness in AI, responsive AI. I hope all of them are going to take us away from such case, but I don't know where that field is going. How much it will bring us to still.
Yeah, it's a very flexible.
Okay, we have 5 more minutes. I want to just see Ian has any comment, any questions to the panelists. Based on, yes, please. You are audible.
Manoj, I have a question for you. This is regarding the quantum state that you have said. So, quantum is not a threat. What do you think the timeline? Because there is a lot of movement is going on in Europe and US, what we have seen. And then Act has already been published by US government that you have to be ready for quantum state. Where do you think that how much time do we have? Because what I see is even in Canada and China, people have started building a quantum state network. So, and we don't see that moment here. That's my first question. And do you think that apart from quantum, will there be any other method which can break the current cryptography? Because what I see is any invention can happen at any time. So there can be an estimation or prediction, but we cannot say that it will not happen. The same thing can happen sure. So do you really confidently say that we have a lot of time? Because when we see from the digital perspective, the digital engineering, the way the applications are getting developed, the plugin, and the underlying securities, RSA, and then so where do you see how much time do we have? Okay.
So there are a few different things here. One is that quantum computing technology, the hardware, there are differing opinions of how far it will go, how fast it will go. There are even quantum skeptics who think it never can be built to a scale where it can solve big problems without ecoherence. So, but then on the other hand, there are a lot of people who are investing in building these big computers. But the point is that there's certainly a lot of time. We don't know how, at least 10 years, you would say. But even if it comes to a point where it can start breaking the current cryptographic schemes, by then you wouldn't have the current cryptographic schemes. We already have candidates for replacing. So the only reason we are using what's currently being used is because they are more efficient than the other ones. So why waste bits on things which are quantum secure or supposedly quantum secure when there is no threat there. So that's one thing. The other is you mentioned this quantum networks, which I suppose you're referring to quantum cryptography networks. That's a very niche technology. Not mainstream. It's not suitable or I would even say relevant to mainstream communication, and it has its own host of problems. Okay, that's not something that will replace our internet. So what we will still need will be cryptography and not quantum cryptography. So you had one more question, or?
Quantum computing is one part.
Can other things go wrong? Certainly. There is no mathematical proof that the cryptography we're working on, that we're using, is unbreakable. It's just a belief based on all the experts failing to break these problems. There could be a mathematical breakthrough. It's considered very unlikely, but who knows? And then the entire cryptography we are using doesn't need quantum computing. That's just a mathematical breakthrough could break all of it, and that'll be a major world event. It seems unlikely based on all what the several layers of body of computer science knows, but it's not mathematically proven that it's possible.
I just want to add one quick comment to that. It may not be about the algorithm. It's about backdoors, traps. You might have recently heard one famous thing, right? That XLZ, that labels you open source encryption algorithm. It's basically compression algorithm. It's an open source, but somebody has put a backdoor in it. It's the open source. It is everywhere. Most of our Linux distribution will have it, but somebody figured out there is a backdoor in it. Who put it? Nobody knows. Maybe it's a state actor who put it.
such a thing which is in each one of our machines, if there is a vulnerability in that, then what? No, algorithms can't do anything.
So there is no harm in going for upgradation from RSA to Kaiser.
Well, harmless in terms of, it's less efficient. So why would you want to do that unless you... But anyway, RSA is actually, the electrical cryptography is what's currently used. Yeah, that's considered fine right now. And there's also a risk in moving to these new, lattice-based cryptography, because they're also fairly new, and for all that we know, they might be vulnerable. There were other candidates recently broken, there was something called, there are quantum resistant candidates for quantum resistant cryptography that got broken classically, right? So, if you're told you want to use something, you would want to use them in combination. You would want to use the current standard and do something on top.
I wanted to stop, but I will not resist.
Good evening, late evening rather. So I am from the Navy, and we are in the implementation. In the field of implementation, we don't create technology; we try and use that to defend our shores. And I have always been of the firm belief that if it is Indian, it's difficult to crack. Now the problem is that all the AIs and softwares and everything that we do, even it's an open source, it's all not Indian. It's not made in India. So do you think that if these things are made exclusively in India, we'll be less vulnerable to any kind of cyber attack?
Also, I think so obviously, I think the technology which are global, those are widely penetrated, so your attack exposure is more, right? So that way, the probability of those getting exploited is more vis-a-vis indigenous technology, right? If we create an indigenous technology and leverage only within India for our defense, obviously the penetration would remain within India, and you are not going to probably make it maybe open source, or it remains, right? So your attack surface is going to be relatively less, right? And thus the exploitability. But whether it can be broken or not, yeah, certainly it can be broken, because you are not going to build. You would certainly use some foundational components which are already available, right? For example, you are not going to build your own kernel. Possibly yes, also, right? But if you are
Why not?
Sorry?
Why not? Why shouldn't we build that?
No, absolutely. I think there are efforts where I think it is been built from ground zero, where you are building your entire kernel and then entire subsystem on top of it, where your attack exposure really reduces, right? So the possibility of exploitability is going to be really less vis-a-vis the global technology.
Okay, I think we are already running late. With this, I would like to conclude this panel discussion. Thank you.
Professor Manoj? I request Professor Manoj to kindly felicitate Professor Manoj.